Forlab project is a research and development project funded by the European Commission under the FP7 program in the security call. We are now in the Center of Operative Practice of the National Police of Spain in Linares at the south of Spain. We have been here making testing of our system that is complete, and now we are for the final testing here. During these days we have been making or simulating two scenarios for testing our system. We simulated a scenario of a terrorist attack into a tunnel at a metro station or train station, and we also simulated a terrorist attack with a post-send explosive device into an office.
Forlab is a system to support forensic investigation in the collection, review and analysis of evidence directly on the field. It is built upon several components. 3D Platform is a 3D scanning platform for forensics and events reconstruction directly on the field. The platform provides a global scene understanding by live 3D map visualization, CSI operators live tracking, Wi-Fi apps localization, FCLS setup, and evidence accurate localization, mapping. A robust, anti-tampering and efficient radio frequency-based architecture is required to serve communication and positioning purposes. The solution, developed in the frame of Forlab project, is highly optimized for the special conditions of the post-blast scenario. The architecture implements the communication and positioning module and serves as the binding bond of the Forlab subsystems by enabling safe bidirectional data exchange between the explosion field and the command and control center. A laser-induced fluorescence (LIF) sensor has been designed and assembled to help detection and identification of plastics and polymeric materials. A high-efficiency pulse laser source induces the material autofluorescence. Substantial reduction of the time needed to scan the large areas is obtained by using large divergence and high repetition rate. The objective and the optical signal detector collect the induced autofluorescence in the visible and ultraviolet spectral range. Objects' locations then allow texturing of the 3D scans and scene reconstruction with LIF-generated images. The LIBS Raman man-portable sensor developed in Forlab has been designed to promptly detect and identify the explosives and precursors used in post-blast scene. The laser-induced breakdown spectroscopy, LIBS, uses a high-intensity pulse laser focused on the sample surface. The obtained emission spectrum enables the identification and quantification of the components in the sample. Raman is a spectroscopic technique based on inelastic scattering of monochromatic light. The combination of LIBS and Raman spectroscopy allows obtaining more reliable results and increasing the number of substances unambiguously identified. The principal forensic application of the LIBS-Raman combined sensor is the fast chemical analysis of evidences in the field, allowing a real-time screening, the detection of traces of different substances, the classification of evidence to identify its origin and composition. Another sensor developed in Forlab is a non-linear junction detector, NLJD, designed to locate and detect the presence of electronic devices, regardless whether they are switched on or off. The NLJD sensor irradiates a high-frequency RF emission. A non-linear junction receiving this energy will act as rectifier, radiating back a portion of the incident radiation on the harmonics of the excitation energy. Crucial for the full exploitation of the information gathered by the different technologies at work on the crime scene is the command and control center. The Design Command and Control Center includes the integration of sensor-specific data acquired by the sensors on the field. The center receives, processes and displays messages from all the deployed sensors, providing a global near real-time view of the investigation. In the first step, the communication and positioning module is deployed and the network established. The 3D scanning is performed to create the 3D model of all zones under investigation. The model is then sent to the Command and Control Center. LIF system is deployed in the desired area on the crime scene. The reference points for LIF are acquired and transferred to the system. The LIF sensor performs scanning and sends the results to the 3D model and Command and Control Center. The LIBS Raman sensor is deployed on site to obtain the fast identification of the materials used for explosion. All the data are sent to Command and Control Center. Non-linear junction detector is applied to detect and locate the electronic devices. The Command and Control Center receives, processes and displays evidences submitted from all the deployed sensors to provide a global, near real-time view of the investigation. As evidences are received, they are displayed in context in a 3D recreation of the scene, which becomes more detailed as more data and 3D scans are received. Supporting data submitted with evidences can be displayed in a multi-windowing environment as interactive spectra, photographs, playable audio files, or as 3D models in the recreated scene.
We did quite successful testing these days, and today and yesterday we had a workshop with the end users to communicate the results of our project, and also a demonstration of the system with a third scenario that has been the explosion of a bomb on a car.
During this week we have seen some different scenarios, explosive scenarios. We have seen technology on the field, and we can say yes, we have some progress since few months, since 1 year. We have some new product, new technology, a new link between the field and the command center, and I think it could help the technical investigator on the field after a blast attack.
The Forlab concept consists of several functions, and all these functions have matured since the pre-testing in Forlab. And what I witnessed today is that these functions are capable of working together. This is important. And as a summary, I could say that the Forlab concept has really emerged.
All the technologies developed by Forlab are very useful for our work in the crime scene or after bombing. There are a lot of techniques that we can use to make our work easier and faster.